Welcome back to the Panchayat classes. Matthew. After one day gap, actually I have not uploaded any video last 2 days or one day. So today I will discuss, or I am going to discuss, very interesting topic, very interesting matter, very interesting matter of class 9 physics, which is very important. We all know the three laws of motion of universe, which is developed by our respected or well-known scientist Newton, Sir Isaac Newton. And today I am going to discuss his second law of motion. Okay, second law of motion. Class 9. Students, second law of motion. This is important. Mm, Suppose here is an object. Here is an object, students, of mass. Mass of this object will be m, and it is at point A. Clear? After time t, and at this point, this object is started with velocity, velocity u. Okay. Initial velocity, that is initial velocity of the object is at point A, and this point is considered to be A, is u, and mass of the object is supposed to be m. After time t, if I applied force F on this object, after time t, object will be changed its position from A to B. Object will be changed its position from A to B. It means at point A, the velocity of the object is u and mass of the object is m. If I applied an external force F on this object, after time t, the velocity will changes from u to v, that is final velocity of the object. Final velocity of the object is v. Clear? Which is at point B. Students, before discussing the second law of motion, we must have knowledge about momentum. Momentum of an object. Momentum is related to the second law of motion. What is momentum? Suppose an object moved with velocity m, moved with velocity v of mass of that object is m, then momentum of that object, momentum of the object is given by mass into velocity. Mass into velocity. If mass of the object is m and velocity of the object is supposed to be say v, then momentum is equal to mv. We can calculate momentum by this expression also. From this you can able to obtain the SI unit of momentum also. That is, suppose say mm, mm, SI unit of mass is kg and SI unit of velocity is meter per second. That is SI unit of momentum. SI unit of momentum is equal to this kg meter per second. Clear? It is clear. I hope it is clear. No? Then I am going to, then you can enter into the uh, second law of motion. Clear? Once again, students, I have to forget to bring this. Huh? So, the SI unit of momentum is kilogram meter per second. Now you can able to understand second law of motion. According to the second law of motion, it means second law of motion states that clearly, I hope you will listen clearly and keep attention on this statement. According to the second law of motion, applied force on an object, it means external applied force on an object is directly proportional to the rate of change of momentum. Clear? Momentum is important for second law of motion, is not it? It is important. Therefore, I have discussed first momentum. What is momentum of an moving object? Clear? So, according to the second law of motion, according to the second law of motion, what does laws of second laws of motion states? It states that applied force or rate of change of momentum of any object, rate of change of momentum of any object is directly proportional to the unbalanced force, applied unbalanced force. I hope you have concept about balanced and unbalanced force. If not, please write your view in suggestion box. Please write. Don't forget to write that. Okay. Now the applied force is here is F. According to the second law of motion, applied force F is directly proportional to the rate of change of momentum. Here you can calculate, you can have initial momentum, initial moment, initial momentum, initial momentum. Initial momentum is equal to mu and you have final momentum. Final momentum, that is final velocity of the object is v and the initial velocity of the object is u. Therefore, initial momentum of the object is given by mass of the object is m into u, that is mu, and the final momentum of the object will be therefore mass of the object into final velocity. Clear, students? Therefore, it gives, you can write this like also. Rate of change of momentum is given by change of momentum divided by t. sense of momentum divided by t. It can also write like this, delta p. Okay, F is proportional to, this is the sense of momentum. This represents sense of momentum. Sense of momentum is P2 minus P1 by P. That is, F is proportional to final momentum is equal to m into v minus initial momentum is equal to mu divided by time taken is t. Now I have to take a proportionality constant, and the proportionality constant will be k. Okay. Therefore, it is because I have to abolish the symbol of proportionality. Therefore, I will take a proportionality constant k mv minus u divided by t. This is, I hope, cleared. Okay. Now from here students, you can write from here f is equal to k into v minus u by t. Again students, a is equal to v minus u by t. This is acceleration of the object. That is, acceleration of the object is given by a is equal to v minus u divided by t. Acceleration is a. Therefore, v minus u by t, m into v minus u by t is a. F is equal to k into ma. Suppose say if k is equal to n, then f is equal to ma. This is the second law of motion. This is the second law of motion. Second law of motion is equal to f is equal to ma. Clear students? This is the proof of second law of motion. And second, again, I just want to discuss it briefly, quickly. Second law of motion states that rate of change of momentum of an object is directly proportional to the applied force. And if F is applied force on this object m, mass of the object is m, and initial velocity of the object is u, and final velocity of the object is v, then F is proportional to delta p by delta t. F is proportional to p2 minus p1 by t. p2 minus p1 is sense of momentum. p2 minus p1 is sense of momentum. That is, final momentum is equal to mv, and initial momentum is mu. That is mv minus mu. And F is equal to kappa k into m whole into v minus u by t. V minus u by t is acceleration of the object. Therefore, F is equal to k into ma. If k is equal to n, then F is equal to ma. This is the second law of, this is the expression of the second law of motion. Second law of motion. This is important for you. This question generally asked in the class 9 standard as well as in the 11th standard. I will discuss this for 11th standard in different manner. To understand, for 11th standard students, you must have knowledge about differential calculus and integral calculus. Applying differential calculus and integral calculus, you can able to prove this F is equal to ma. Clear? Have a good day.